Hello everyone, welcome to the video on applications of non-classical logics to the metaphysics of quantum non-individuality. My name is Jonas Becker Arenhart, and I have been researching on this subject for a little more than 10 years now. And this is a fascinating subject because it combines three different areas: quantum mechanics, logic, and metaphysics. Well, as you know, quantum mechanics is by itself a source of inspiration already very well known for suggesting revisions of logic. There is a classical discussion on how quantum mechanics suggests that the distributive law in classical logic requires that we revise classical logic. So quantum mechanics has already some track records on suggesting revision of logic. Now, this is not the only way that quantum mechanics has already provided for this kind of suggestion. There's a different set of problems that is not associated with distributivity, but now with notions of identity and individuality, and in which quantum mechanics also suggests logical revision. So basically, there are some suggestions coming from different sources to the effect that quantum mechanics and the individuals that quantum mechanics deals with are not individuals in the classical sense. So basically, the plan is that for entities that are dealt with by quantum mechanics, identity does not fully apply. And this happens because the notions of identity, which is a logical notion, and the notions of individuality, which is a metaphysical notion, are seen as closely connected. So whenever individuality fails, identity fails too. So if quantum mechanics is suggesting a revision in individuality, it is also directly suggesting a revision in logic. So the issue is very interesting because we have a very successful physical theory that is suggesting a revision both in logic and in metaphysics. Basically, the idea is that if it were not for quantum mechanics, we would not think about applying a notion such as non-individuality. We would not think that the idea of that the objects surrounding us are not individuals could happen to fail. So thanks to quantum mechanics, this suggestion appears, and it seems to suggest in a connected way that classical logic is having trouble to deal with that. So in this sense, we have this connection of these three major areas, and this is a very interesting subject. Let me share with you now my slides to present in more details what is going on, so that you may see how the three areas are connected. There we are. We are willing to apply non-classical logics to quantum mechanics, and specifically to deal with these entities, these quantum entities that are said or thought to be non-individuals. Basically, they are not individuals in any classical sense. Let me start telling you how did this idea first appear. I have this quote by Schrödinger, the same Schrödinger that suggested the famous Schrödinger cat. So to let you know that the idea that some entities are not individuals, although it is a kind of logical and metaphysical idea, it did arise in physics directly from quantum mechanics. So basically, Schrödinger is describing the nature of quantum particles, and he's saying this essay, his essay, of course, deals with elementary particle, more particularly with a certain feature that this concept has acquired, or rather lost in quantum mechanics. I mean this, that the elementary particle is not an individual. It cannot be identified. It lacks sameness. So this is the feature that quantum particle has lost. It lost its individuality, which is a metaphysical notion, and it cannot also be identified, which is an epistemic notion, and it lacks sameness. And this is how Schrödinger expressed the idea that we cannot express that one particle is the same or different as another, that this idea goes by the board in quantum mechanics. You just cannot say that one particle and another particle are the same or different. So loss of individuality means all these different things, according to Schrödinger. And he explained why quantum particles have lost individuality. He says, in a technical language, this loss of individuality is covered by saying that the particles obey a newfangled statistics, either Bose-Einstein or Fermi-Dirac statistics. The implication, far from obvious, is that the unsuspected epithet "this" is not quite properly applicable to, say, an electron, except with caution, in a restricted sense, and sometimes not at all. So basically, what he's saying is that these things are no longer individuals, they are not identifiable, they are not identical or different, we cannot say this. And the source for this feature that the particles have lost is basically quantum physics and the new quantum statistics. So let us check it very quickly. What does it mean? Or why do these statistics are thought to generate these metaphysical difficulties? Because then we can see how logic is required to change in order to account for this difference too. If we consider classical entities from classical physics, and we think that we have two particles, let us call them A and B, and if we are willing to distribute them into two boxes, box 1 and box 2, then basically we have four different ways to do that. We can have particles A and B in box 1, particles A and B in box 2, particle A in box 1 and B in box 2, and changing them, box B in particle B in box 1 and particle A in box 2. So the very general the problem comes from these two different ways of counting, because if we change particle A with particle B, we are having a very different situation. It makes a difference if it is A that is in box 1 or if it is B. So in classical mechanics, it does matter which particles is in which box. Now, if we go to quantum statistics, and this is Bose-Einstein, we can have also the two particles in box 1, the two particles in box 2, but when it comes to distribute one particle per box, it does not matter which particle is in which box, because if we switch the particles, it will not generate a different situation. That's why they are written here without labels, and also with just one possible situation, because if we switch these particles, nothing happens really. So we have only one situation where one particle occupies one box. And this is the major difference between quantum statistics and classical statistics, according to Schrödinger. And the point is that while in classical mechanics it makes sense to ask which particle is in which box, there is something to them, their individuality, that should be responsible for this. So it is A or it is B, it is this particle and not that one. This is lost in quantum mechanics. We cannot say that it is this particle that is in this box, because if we switch this particle with the other particle, then still nothing happens, nothing changes. Then that's the point of saying that we lost sameness and we lost individuality. There's nothing to back up a difference in the situation before and after switching these particles. So we lose the particles' identities and individualities. That's how the story goes. And this is connected to the metaphysics of individuality, when we check that we have two major approaches to individuality. We have the bundle theories. Basically, It says that an entity is a bundle of properties, so an individual is nothing more than the properties it instantiates. And different individuals are different because they have different properties. So we cannot have different individuals without also having a difference in their properties. This approach is thought to be violated in quantum mechanics straightforwardly because there is no property that can distinguish different electrons or any other kind of quantum particle. So at least in general, there is a kind of view that the bundle theories fail in quantum mechanics. And there is another option. Transcendental individuality is really a bundle of options. There are many options that fall under this label. And these are views on individuality which account for individuality by adding some extra ingredient. Okay. It may be a substratum in the tradition following Locke. For instance, so different individuals are different because they each has its own substratum, which is primitively individuated. Or else we can account for individuality not in terms of a kind of particular item, the substratum, but in terms of a non-qualitative property, which is a property that is not a quality. So, and it is typically called a haecity. So Plato's different from Aristotle and different from Socrates because Plato has his own haecity and Socrates has his own aecity and so on. So, and what's interesting in this kind of approach is that a haecity is framed in terms of the property of being identical to itself. So Plato's haecity is the property being identical to Plato. Aristotle's haecity is being identical to Aristotle. It is non-qualitative because it does not add any quality to the thing. And what is so interesting about it? Well, it's interesting because while it is typically thought that bundle theories fail for quantum individuals, for quantum particles, transcendental individuality also failed because we can shift the particles and nothing really happens. And if we think that self-identity is precisely the mark of individuality, then we can have a very nice way to represent in a non-standard logic the failure of individuality. So how should it go? I quote here from the very nice and still the major reference on the subject, French and Krause's book, Identity in Physics. And they connect physics with metaphysics and logic in the following terms. The idea is simple. Regarded in Heseistic terms, transcendental individuality can be understood as the identity of an object with itself, that is, A equals A. So that's basically how haecities go. If you have a haecity, that means that you are identical with yourself. So classical logic would imply that everything is an individual because everything is identical to itself. So, they say, we shall defend the claim that the notion of non-individuality can be captured in the quantum context by formal systems in which self-identity is not always well defined, so that the reflexive law of identity, namely, for every x, x equals x, is not valid in general. So there we have the connection. Basically, if we say that physics suggests that individuality and identity fail, then we find the corresponding metaphysical notion, haecity, which is represented by self-identity and which is failing, and then we can represent this in logical terms by violating the general validity of self-identity, of the reflexive law of identity. So we have a kind of unification of the three big areas that we are talking about. And then the plan seems to be that quantum mechanics is suggesting that one of the most basic laws of logic is really restricted, to say the least, if not violated. So in this sense, we have this direct connection going from quantum mechanics to metaphysics and finally to logic. So what are the systems of logic that do this? Well, they are very simple systems. In formal terms, their interpretation is quite difficult, but The point is that we have Schrödinger logics, named after Schrödinger, of course, because of his being a source of inspiration. They were suggested by Newton da Costa at first, and then generalized and developed by Krause. I think that still one of the best presentations is in the book of French and Krause I mentioned. And in formal terms, these are simple systems. You can think of them in terms of first-order languages that are two-sorted. So you have two kinds of terms. We have the classical terms, that means individual variables and individual constants. And we have also the non-classical or quantum terms, which are also individual variables and individual terms for quantum entities. So if you think that the classical terms denote classical entities and quantum terms denote quantum entities, the plan is that quantum entities are not individuals, they are not self-identical. And this is represented by the fact that for classical entities, self-identity is defined, but for quantum entities, this expression of self-identity is not even well formed. So we cannot express that they are individuals by restricting the very definition of formula. You just cannot say this. This cannot express self-identity. So this is one way to represent that they lack heities. They are non-individuals in the sense that heicity fails for them. The same idea can be generalized to a theory of sets, which is called quasi-set theory. It was developed by Krause too. And again, the classical source is the book of French and Krause. Basically, again, we have two kinds of atoms. So this is a set theory with atoms. We have the macroatoms that are the classical objects and the microatoms, which are the quantum objects. And again, by using the same kind of trick that we used in Schrödinger logics, identity is not defined for microatoms. The plan is that in quasi-set theory, we define identity, and the definition holds only for macroatoms, the classical objects. And so, by using the typical set formation techniques, you can form collections of both kind of atoms. And given the fact that for microatoms there is no identity, we have some obstacles and some challenges to account, for instance, for cardinality attribution. It's a bit more difficult to say how many elements there are in a set, given that the typical counting procedures are not available. But all these obstacles can be dealt with, and the theory is very interesting, and we can say how many elements there are in a set, even without counting them in the usual way. So we don't need identity to count these entities. It's very interesting. And in quasi-set theory also, we can prove a very interesting theorem that on what concerns microatoms, we can permute them, we can exchange microatoms in sets without giving rise to different sets. So that's precisely what the statistics for quantum entities was telling us. So this result from physics is reproducible in quasi-set theory. You can permute atoms without giving rise to different sets, or quasi-sets in this case. So both theories one can find them very well presented in this book by French and Krause to begin with. So this is a very nice place to start reading about them. But still, there are some additional problems I would like to mention to you as a final step. Basically, the idea that quantum entities are not individuals, as Schrödinger was suggesting, is not completely established. So it's not obvious that quantum entities are not individuals. One can, with full sense, say that those entities are individuals, but that they are just indiscernible. So what accounts for their permutability is that they all have the same properties. So there are some senses of individuality that do fit with quantum mechanics. And then basically we have the famous metaphysical underdetermination. Quantum mechanics does not decide whether it has a metaphysics of individuals of some kind or of non-individuals of the kind we are describing. And also, there's a problem with the idea of non-individuality. As you have seen, in order to represent non-individuality in terms of non-reflexive logics, we have described non-individuality as failure of identity. But that requires that individuality be understood in terms of haesities. So that's a very specific notion of individuality that results in a very specific notion of non-individuality. But given that there are other notions of individuality, as for instance, being in a certain position all the time, so that's space-time individuality, so different individuals have their individuality attributed by their different positions. We also have different notions of non-individuality, so this failure of having a very specific position, in this case of space-time individuality. So it is not clear that all versions of all definitions of individuality will give rise to the same to versions of non-individuality that require change of logic. So it is not clear that having non-individuality means the same as failing identity, because you can have non-individuals and still have identity in some versions of non-individuality. So thanks to this kind of study, we can see that there are so many options already open, and not all of them lead to logical revision. So this is still an issue of logical theory choice and also of metaphysical theory choice, which is basically the challenge most of the time when it comes to metaphysics and logics. So this is not different from other situations where non-classical logics are said to apply. So these are the references, and thank you very much for watching.